So let's look at the last part of our notes, and hopefully this will help everything kind of make sense. I'm going to just highlight the F so I can keep it separated from G. Notice F, this is an open circle. That means there's nothing at that place. Let's count this out so we kind of have an idea of where we're at. This is 1, 2, 3, 4, 5, 6, 7. This one goes over to 8. This is negative 1, 2, 3, negative 4, negative 5, negative 6, negative 7, negative 8. That'll keep it from having to count it out every time. All right, let's think about the domain of F. F is the pink function. So what value for x? It goes to negative 8. And F goes all the way to x's positive 7. So the domain for F is negative 8 to positive 7. Also, 7 has an open circle, doesn't it? So it should be negative 8 to positive 7, but 7 has to have a parenthesis because there's no point there. All right, let's talk about G. G starts here at negative 7, and it goes all the way to positive 8, but again, this has an open circle, so I would say it goes from negative 7 to positive 8, but 8 has a parenthesis. So what this tells me then is whenever I'm multiplying and dividing, the domains are only going to be where they cross at. So they cross from negative 7 all the way to positive 7. But 7 has an open circle, so it will have a parenthesis. And it's going to be the same for this, except for there could be a place where it doesn't work. I'm going to look for G as in the denominator, and we don't ever want G to be 0. So where does G equal 0 at? Right here at negative 3, and also over here at 5. So we have to say that G cannot be 3, negative 3 or positive 5. Now, if you're doing delta math assignments, it doesn't get this deep, but you'll need to know it for college algebra. All right, let's go find some composition functions. So I want to find G of F of negative 7. So I'm going to start by finding F of negative 7. So I'm going to go to negative 7 and go up to the F, and that is 6. So this crosses off and becomes a 6. So now what I'm finding is G of 6. So I'm going to go over to 6 and up to or down to G, and it is negative 2. All right, let's find F of G of 3. So I'm going to start by evaluating the G function when the input value is 3. So I'm going to go to input of 3 and find the G function, which is 4. Now I'm going to find F of 4. So I'm going to go to 4, and the F function is the pink function, and it is 5. Let me make sure I did that right. G of 3. Did I? 1, 2, 3, and G is the dotted line. 1, 2, 3, 4. Okay, and now I'm going to go to 4. 1, 2, 3, 4, 5. That's right. Okay, let's find F of 1. So I'm going to evaluate F at 1. The F function is the pink function, which is 2. And now I'm going to evaluate F at 2, which is 4. The last one, let's find F of G of 0. So I'm going to go to 0 and find the G function, which is 6. Now I have to find F of 6, which is 1, 2, 3. And the F function is the pink function, so it is 3.